Right, so we would like to present the Electron Framework vulnerability found by our security researchers at BAE System. Our talk, Breaking Barriers Using XSS to Achieve RCE, will focus primarily on the misconfigured Electron apps that could lead to the RCE via a simple cross-site scripting bug. This research was first presented in Black Hat 2022, entitled Electron Vault by Mohan Sri Ramakrishnan, Max Guerrett, and Adiyata Purani. Our research is based on one of their case studies. We decided that this topic is right down our area of specialization because all our security researchers are actually web pen testers. Therefore, finding the XSS in and RCEs via either source code analysis or gray box testing is definitely something that we were confident that we could find results within a short period of time. So our research started in early January this year. We took a few weeks to examine previous research from other security researchers out there, and we explored if we could emulate some of their findings further. A lot of the information on our research was already out there. We just had to piece together and find the right apps with the correct misconfiguration, and also hunt for that XSS vulnerability to trigger the RCE. For those of you who are unaware, the Electron Framework is a free and open source software framework to develop and maintained by the OpenJS Foundation. The framework is designed to create desktop applications using web technologies that are rendered using a version of Chromium browser engine, and at the back using the Node.js runtime environment. What this means is that the Electron app is quite versatile. It can run on major desktop operating systems such as Mac, Windows, Linux. Some very popular apps that you might have heard of, including Discord, MS Visual Studio, Microsoft Teams, Slack, GitHub, Desktop, Trello, and many more. We soon discovered that the XSS to RCE bugs for these apps were already reported by other security researchers. So we hefty bounties already paid out. However, that does not mean that there are no similar bugs found in other lesser known apps in Electron. So our hunt begins. The vulnerability is a combination of two issues. A simple XSS bug at the application layer, and misconfiguration at the Node.js configuration. To mitigate this vulnerability, the NodeIntegration function was already set to false in all Electron frameworks starting at version 5, which means that the renderer process does not have access to the Node.js APIs. Similarly, the NodeIntegrationInWorker option was also set to default set to false, so that the Electron workers do not have the access to the Node APIs. This helps to prevent the this helps to prevent the malicious code from executing in the renderer process and accessing the sensitive system resource. However, if the developer still requires the node integration to be enabled, he or she would need to explicitly enable it in the Electron Node.js configuration. Our security researchers was able to identify dozens of misconfigured apps written in the Electron framework that are publicly available on the internet. These misconfigurations could have led to RCEs if a simple XSS vulnerability was present in those apps. Our researchers also will demonstrate the techniques that we use to exploit these vulnerabilities by chaining the XSS to RCE. Some of these vulnerabilities are pre-auth, meaning no authentication required. Thus can be easily exploited in the wild without user interaction. So we call it zero clicks. At the time of writing, BAE Systems researchers had found at least three popular apps hosted on GitHub. These apps are fairly widely used on the internet that are easily exploitable via the zero-click exploit POC that we have developed. We had reported all these vulnerabilities already to their respective application owners. Therefore, they're all fixed. However, there's still residue servers that are exposed on the internet, which we will show you. So our first finding will be presented by Ali. And Ali, should I give it to you now?
All right, thank you, Rizan. So, hello everyone. I will be presenting the first app called Trillium, which is an Electron-based app of note-taking. So I did some research to look for interesting Electron-based application, and I discovered that in the website of Electron.js, they have one section called apps where you can search for any Electron-based application by category or by searching some keywords. So what I did is I'm looking for a note-taking app, so that's why I'm searching for Node. So based on the results, there is a Trillium, and if you are not using their website, you can also use a GitHub search. So basically, you just go for their repository, Electron-/apps, and you can use the GitHub search filter to search for any interesting Electron-based application that you want. So what actually is Trillium? Trillium is a note-taking application. If you are familiar with Obsidian or others note-taking app, Trillium is similar apps like that. So they have quite numbers of users that are using it. They have a lot of features. One of it is what you see is what you get editors. But the most important thing is it is an Electron-based application. So to ensure that the apps that I'm looking for is a good app for me to start this research, the first thing is we need to confirm whether they have the config that we're looking for, which is node integration equal to true. So in my case, the config for Trillium, they show that they have the config of node integration true. So if I manage to find any XSS in this application, I might be able to escalate it to RCE. Also, one thing that I learned, it's good to look at the previous report by other security researchers. So I'm looking at the Hunter Def, and you might get a higher chance to find the similar vulnerabilities again on the application that you are targeting. So let us start looking at the walkthrough of the POC. So once I install the latest versions of Trillium during that moment, the first thing that I did is I tried to inject the XSS payload in any possible user input, like in the body, in the title, and so on. But it didn't trigger any XSS at all. Suddenly, when I tried to search or inject an XSS in the search that start with double quotes, then it suddenly pop out an alert. So at this time, I'm confident that one of my payload is triggering this, but I'm not sure where. So the simple methodology that I use is we use a numbering in our payload. So for example, in the title, I use alert 1, in the body, alert 2, and so on. So with this simple methodology, what you can do is when you trigger the same XSS, you will see that a number is pop out. So right now, I could confirm that this one is coming from the title itself of the nodes. So now we confirm that there is an XSS vulnerability. So the next step will be on how I could escalate this to RCE. So we know that the application of Trillium, they have the node integration true. So the common payload for Electron-based is to use require to access the child process and to execute any command that you want. So this is one of the simple payload that I tried. As you can see, I use double quote to require child process and execute calculator. But when I use this in the title and trigger the XSS, there is an error in console, which it says unexpected token. So I suspect that double quote is the reason why my XSS is not working. So let us try with a single quote then. It is a replacement for the double quotes. So by using this single quote, I try again. it also gives me an error of unexpected token. So right now I know that there is some restriction or limitation of payload that I'm using. But no worries, in JavaScript there are 3 methods that we can use from what I know. So double quotes, single quotes, and also backtick. So when I try with the backtick, the same payload only changed with the backtick, and now it's working, and my payload is working when it shows a calculator pop-up. But it's not end there. Instead of just pop-up calculator, I want to get a reverse shell. But I'm stuck for a while on how to bypass all the limitation and restriction that I encounter in this Trillium. So it's not only double quote or single quote that I can use, there are some more special characters that I can use. But maybe I'm thinking in a hard way. Sometimes you don't even need to bypass this restriction. So let me show you an example. So this is the payload that I would like to execute, which to use the child process and get a reverse shell using the bash script. So in this payload, they have double quotes and some special characters, which by now we know that it's not working in the payload itself. But what if we just use a simple payload as this? So there is no special characters like double quote or single quote. So what this payload is doing, we just load an external JavaScript, and this JavaScript will hold all the payload, and it doesn't care if you're using any special character. So by using this simple payload, now when I'm using the search function again, then I will get a reverse shell. So you might know how an attacker would abuse that things. So I did show some POC of video on how attacker could send the victim a zip file that contain a malicious Trillium apps. So that one you can check in the Hunter Dev issue in the video itself. So now we're going to move from a node taking app to a database management app called dbgate. So this application dbgates contains a zero-click RCE, which could allow an unauthorized users to access the global and the process object, which could lead to RCE. So what is dbgate? dbgate is an open source management tool that allows users to connect to various databases, and they provide features such as data browsing, SQL query, and also data visualization. But the most important thing, it is an Electron base, and it can also install in multiple OS like Windows, Linux, or Mac OS. So the same method as the first application Trillium, we mainly use GitHub to search for this vulnerable application that might help us on this research. So the same node integration through can be found in these dbgate applications. So that's how I found out that this dbgate might be a good target for me to research. So in this dbgate application, they have one feature called JavaScript shell. This feature has the ability to execute JavaScript. So when I try with alert, it doesn't working. It gives an alert is not defined. So I want to confirm whether this feature can really execute JavaScript or not. We can just run a simple console.log, and when I run it, it's working when it shows that the response is what I expected. So the JavaScript shell is working. So the next step will be on how we can enumerate what kind of objects that I could access. So I created a few lines of codes that print out only available objects that I could access in this feature. As you can see, there is a few output in there. There is a global, process, and require. But the require is null. So when I check the script on the application, so before it runs our script, it will define require equal to null. So that's why the results say that require is equal to null. But since we have the access to the global and the process, we can also execute RCE or any commands that we want using the process or global to access the main module, and you can use the require to access child process and execute the command that you want. But I keep wondering, like, is this a feature enabled by default or not? So I noticed that it was mentioned in their documentation that it is disabled by default, but when I'm installing it using npm, it's enabled by default. And interestingly, they also have a web version. So this web version is on port 3000, and the same thing, I can also access the JavaScript shells and execute any command that I want. And interestingly, there is no authentication needed, so anyone could access this if they expose this in the internet. So with this in knowledge, I could use a curl command to get a reverse shell or run anything that I want without any authentication. So it is also a good thing when you are doing research in web application. We can use their unique headers, body, response, fav icon hash to find any public instances in the internet. So by using all of this knowledge, I managed to find a total of 41 unique instances that use these applications. So even though that it is not a huge number, but there are some users that expose this in the internet, which could be vulnerable to this issue. So for learning purpose, I made two nuclei templates. One is for Recon and one is for RCE. The reason behind this is for learning purpose. So with these two templates, I also contributed to nuclei templates repository. Good things that they really fast and quick at checking all the new pull requests to their repository. So I highly recommend everyone to contribute in their repository. Yeah, so with that, I will pass to Aden to share the last apps. Thank you.
Yeah, thank you, Ali. So, hi everyone, my name is Aden. I will talk about the final technical findings. It is a zero-click RC vulnerability on this application, Appian desktop, meaning that this vulnerability is not require authentication and interaction at all. The application is an open source tool, is widely used by the mobile app developers, and I will talk about this in the next slide. The early version of the Appian is a CLI interactive, but after that they enroll out the Appian desktop, which is the Electron application, and which give to run the program in a cross-platform like Mac, Windows, Linux without installation. Appian is a mobile app testing framework that support both Android and iOS platform. It uses the web driver to automate the interaction with the mobile apps, which allowing developers to test their application across multiple devices and platforms. As in overall, it is just a GUI version of the app, give you a point and click interface for configuration and starting up the Appian server for seeing interaction logs from the mobile apps. As usual, like what Ali had mentioned earlier, before we look into the application, we will look into the configuration file of the Electron app to confirm that the integration is not integration is enabled, as it will give us an opportunity to achieve RCE on the app if we manage to discover a simple cross-site scripting on the application. I will go in to show a demo video how I exploit this vulnerability. So this is how the Appian application looks like, and this you can choose the network interface and also the listening port, and these are the advanced setting. I left this one as a by default. Yeah. So once we start the Appian application, it will open the new windows, and to capture all the web logs from any incoming request to this Appian server. And something came into my mind about this feature is the potential web log poisoning attacks. If I send a simple cross-site scripting payload, to the target application, and it will trigger the cross-site scripting in the web console. As we can see, the payload is very simple cross-site scripting, just an alert, yeah. So for here, we can see that it actually triggered the cross-site scripting, and this means that there is no input validation on any incoming request, and this is not requiring any user interaction as the web console is running in the real time. Now we know that it is vulnerable to a cross-site scripting. As I showed in the previous slide, that the node integration is enabled on this Electron application. So now we can try to exploit the cross-site scripting to RCE to open the calculator. So I changed the cross-site scripting payload to use Node.js modules to open the calculator. As we can see, when we send to the server, it will poke up the calculator. Next, to fully demonstrate the maximum impact of this vulnerability, I set up a netcat listener. Yeah, so the netcat is listening for port 4444. So in the payload, actually, I use a netcat to send to connect the reverse shell command. So once we send the payload, I should receive a reverse shell connection to my server. So as we can see, we receive connection from the APN server, and we can run the command. Yeah. Lastly, this is something extra. How can we verify that the target is vulnerable to this exploit without causing a damage to the server? I craft a simple cross-site scripting payload to trigger the callback response on the target to my server. If I receive a callback response from the target server, this confirms that it is vulnerable to this exploit. So in the payload, actually, we are targeting on one of my server domain. And I use the burst suite collaborator as a server. If I receive any request from the target, meaning that this is vulnerable to the vulnerabilities. Yeah. So actually, this is from the APN server itself, from the source IP and the server IP. So that's it for the demo. The same thing I did like Ali. I performed a threat resource analysis on the internet to discover the vulnerable live instance using the HTTP response of the APN desktop application as an integrator. Based on the OSINT result from the census and Shodan, a total of 208 instances were found to be publicly accessible on the internet. They are potentially vulnerable to these vulnerabilities. With the technique that I showed in the demo, in order to automate this process, we created a nuclear template to scan this vulnerability. So the template that I showed in the previous slide, I actually computed and published it to the nuclear template repository, meaning that any of you can use the nuclear scanner to scan the vulnerability. On the other hand, Nexus also released a plugin tool for this vulnerability. I will pass to Rizan to cover out of the disclosure timeline and the remaining.
Thanks, Aden. So we will share the timeline of the disclosure process to the respective application owners. 3 applications were triaged through HunterDev, an open source bug bounty platform that supports thousands of applications hosted on GitHub. Our goal was not monetary, but to obtain the acknowledgement for our research and possibly publications of CVEs. Appium, the application that Aden showed you with the zero-click vulnerability, was disclosed in March. Initially failed to get a response. He had to reach out to the application owner through Twitter. Unfortunately, the application owner will not fix the vulnerability in this app because the application had reached end of life. However, it was agreed that they would inform their users to upgrade immediately due to the vulnerability that we discovered. The other app, both dbgate and Trillium, was reported in March this year. For dbgate, we just received a response from the product owner this morning. They disabled the JavaScript shell function by default on the npm installation. What this means is that the vulnerability is no longer exploitable unless the user explicitly enables the function at installation. For Trillium, it was fixed, but we are still pending the CVE publication and creation. Both applications were triaged through hunter.dev. So this concludes our sharing. We would be more than happy to take any questions after this or anytime now. If not, thank you for having us again. We're very happy to see all of you and hope to see you again. Thank you.